Hello everybody, I am Ben from Team Panic, and ARC, which is my local league, is coming up to having its big middle of the year, I guess, competition. So every year ARC does one big event. Last year that was at Maker Fair. This year it's at Hybrid World, which is another kind of tech conference that's coming into town. So that's all quite exciting, which means though we need a lot of robots in a short space of time. I have signed myself up with 6 different robots. Some of those you already know, including Disguise and my Dustpan robot, Blind Spot, and of course my Toaster robot Breakfast. All 3 of those are going in, but we have 3 other robots that we need to get done before then. The competition is kind of late July. So we're starting this week going back and looking at the vertical design that I kind of sort of showed off in a previous video. At least I showed this particular chassis on camera. However, I had a lot of issues with this. The weapon on this thing is a lot bigger than what I normally run, and so is the motor that runs that weapon. The idea is that this thing is going to have a big brushless motor on it, and it's basically going to be direct drive, and yeah, we're going to see how we go. It's the idea for a lot of these robots that we're about to see is going to be hitting as hard as I possibly can, rather than doing something weird and wonderful. I've already got the weird and wonderful robots built, I've got Disguise, and I have Breakfast, the toaster robot. So now we're going to build some stuff to hit as hard as we possibly can. Now, the reason that this chassis never had anything happen to it was because I tried to load it all up and I found that it was hilariously overweight. So this time around we're going to do something about that. Now the reason this guy was overweight is I tried to put my Arduino system in here. Now the Arduino system was designed to be really cheap, but it wasn't really designed to be all that lightweight. It was lighter weight than the components that we were using 3 years ago, but these days we have things like this. So this is an N20 motor, which is the pretty standard amp weight motor, with an actual motor controller built into the board on the back of it. So this whole thing weighs a couple of grams extra than an actual N20 motor, and it has the motor controller in it. But this motor controller, basically needs to run with an RC system. I could run it off my Arduino system, but I've found some really, really small RC gear. So we're going to try and run this with some small RC gear, and that's going to cut a lot of weight out of the electronics. So hopefully with that we can actually get the weight to build this. Now I'm kind of counting on this weight reduction to be pretty significant because we're also going to change this. So this here is the motor mount. The motor is supposed to mount in here, and then a vertical weapon spins up in here. However, this is just 3 millimeters of plastic, and I have a feeling this is going to snap in a competition. In fact, I can pretty much snap that by hand right now on camera. So that's not good. So what we're going to try and do is we're going to try and epoxy a 3 millimeter slug of aluminium in there and bolt the motor directly to the aluminium, and yeah, like I said, epoxy it into the bodywork so that everything holds together nicely. So I need even more weight than I had in here. So what I'm really hoping is that the weight reduction from the new really small electronics is going to help with some of that. Anyway, that is enough talking. Let's fire up the printer, get a brand new shell printed, and then yeah, start working on the new motor mount, because that one's gone. So there you go. I am so happy with this. Right now, as it currently stands, it is 3 grams underweight, so I'm going to put a top cover on it just to hold all the electronics in place a little bit better. Obviously, the tape is not the greatest solution to that. And also, we're going to change the wheels over to be purple silicon outers, but just for today and getting the tests done and stuff, I just whacked some green wheels on that I already had made up. But wow, this thing packs a punch. That weapon is incredible. I need to be really careful with it though, because as you kind of saw at the last little bit there, I can gyro dance with this weapon, which is not something I've ever had with a weapon before. And if I gyro dance too much, I end up upside down, and I need the weapon to keep moving because it doesn't have enough torque to flip the whole robot back over on its own. It needs to be spinning as I hit the ground for it to actually keep the robot up and right way around. So it's going to be a bit of an interesting one trying to drive this thing around. I'm probably going to have to cycle the weapon up and down quite a lot as I'm driving it to try and avoid that gyro dance, but when it does hit, holy cow, it takes a punch. So this thing here, the orange part is injection molded ABS, and as you can see, it's got a huge crack through the back there. This is not a 3D printed part, this is injection molded ABS, and it is taken a huge chunk out of that, which is really cool. But even better than that, the top clear section here is injection molded polycarbonate, and it's taken a chunk out of that as well. I mean, this stuff is probably not all that thick. I would estimate kind of 1 to 2 mil thickness in this polycarb, but that's polycarb and it's taken a huge chunk out of it, and I am so happy. This thing is going to be incredible when we put it into the arena. I'm looking forward to Hybrid World now. This is going to be great. Obviously though, we've got some more robots to build between now and then, so I will see you next week for the next robot build.